Welcome to the data structure series. Among all the data structures, linked list is one of the topics students fear the most. But today we are going to change that. We will not memorize programs. Instead, we will understand the logic behind every line of code. Once the logic is clear, writing the program becomes very simple. Let's start the journey with a singly linked list. Fine. A singly linked list is a linear dynamic data structure in which each element contains data and the address of the next node. As you can see in the picture, this is an example of a singly linked list. Okay, there are three nodes, 10, 20 and 30. So these are the nodes, the elements available in the linked list. Fine. So the nodes are connected through links and the last node points to null. So you can see that the last node's address part is null. Fine. Okay. So now you have a special variable called head. So this head is a pointer variable that stores the address of the first node. Data field is this one which stores the actual value. This is called the next field. This is called the next, stores the address of the next node. Fine. So now you can understand that a node in a singly linked list is comprised of two parts, two compartments. One is the data and the other one is the next. So it is called as a singly linked list because each node contains only one link, only one pointer which points to the next node. Look, there is only one link to the next node. So 10 is linked to 20, 20 is linked to 30 and 30 points nowhere. It's null. The last compartment is null. So since there is only one link, no link to the previous node is found. Traversal is possible only in the forward direction. So now the question, how should I represent my node? I will represent my node using a structure like this. Struct node, inside the structure I say int data, struct node start next. So struct node is nothing but it defines the structure named node. And int data stores the actual value, say for example 10, 20, 30, and next is the pointer that stores the address of the next node. So this is how I represent my node in a linked list. Fine. So we understood how to represent a node in a linked list. So let's code the singly linked list. So before coding, I'm going to use three important pointers. The first pointer is the head. So this is the pointer that points to the first node of the linked list. So initially my head is null. Then a second one, for creation of nodes, I use some terminology called new node everywhere throughout the program. And the third, I am going to use stem, where this is a temporary pointer variable which I am going to use for traversing purpose, traversal of nodes. Fine. So let us begin with the first operation. The first operation is creation of nodes in a singly linked list. So we have to create obviously n nodes in a singly linked list, right? So what is the basic algorithm for creation of n nodes in a singly linked list? First you read n. So for example, n is equal to 2 in my example. So I initially said head is equal to null. Why I said head is equal to null? Because head is equal to null means the list is empty. So you run a for loop for I equal to 1 till n. So my I is equal to 1. You create a node. So you call malloc and then you create the node dynamically. Now the operating system will give you some space for the node like this. So now the node is created. So after you create the node, you will have something like this, and you say you read the data value of that particular node. Say for example 10, right? And then you say the next part of the node is null. So that is what is being done in B and C portion here. So you read the data and say the next portion of that to be null. So now if head is equal to null, yes, head is equal to null. So make the head point to the new node. So this is my new node created. So now my head is pointing to the new node. Also there is stem. Temp is pointing to the head. So temp is also pointing to the head. So temp is also pointing here. Fine, one node is created. Now I is equal to 2. Yes. So for I is equal to 2, you create one more node. Yes, done. I'm creating the node using my malloc, and then I enter data and then say that this is null. Done. So now B and C part is again over. So this is over. check if head is equal to null. No, head is not equal to null. So temps next, the else part will execute. So temps next is equal to new node. So this is my temps next. So temps next is pointing to new node. So the address of this is copied here and the temp is pointing to new node. Say for example, the address of this is 1000 and that 1000 will be written onto my tens next. So this will be written onto my tens next and this node points to the new node. That's it. We have created two nodes. And moving back to the previous example, look at the chain. So this is the chain. So here I would have created three nodes, 10, 20 and 30. This is an example of a singly linked list. Fine. So now moving on to the program. So how should I code this? Initially get the n from the user and then run a for loop. Inside the for loop, you create the node, you enter the data and then set the next to null. Very important. And then check if head is equal to null. If head is equal to null, it means this is the first node in the linked list. So if it is the first node in the linked list, make the head point to the new node, temp point to head. For the second node, this portion will not work. You have to execute the else part. So make temps next point to the new node and then you create multiple nodes in a linked list. Fine. So this is how you code creation operation in a singly linked list. Fine. Any doubts in creation of n nodes in a singly linked list? Post it in the comment section. I'll be happy to explain. Thank you. Happy learning.